Hi! In this video, we'll be looking at different types of radiation. Some isotopes are unstable. Their nuclei emit radiation to become more stable. There are three main types of radiation you need to know. Alpha particles have 2 protons and 2 neutrons. This is a helium nucleus. An alpha particle has a charge of 2, and its symbol is the Greek letter alpha. Beta particles are just fast electrons. They have a charge of -1, and their symbol is the Greek letter veta. This is pronounced beta in English or American. Gamma radiation is not a particle, but a part of the electromagnetic spectrum. It therefore has no charge, and its symbol is the Greek letter gamma. Exam boards often mention that you need to know the nature of these types of radiation. This just means you need to know what they consist of. You need to know some of the properties of alpha, beta, and gamma radiation. First, let's look at their different penetrating power. This is how easily they can pass through materials. Alpha radiation cannot pass through paper. Beta radiation can pass through paper, but not through thin aluminium. Gamma radiation can only be stopped by a thick sheet of lead or very thick concrete. Alpha radiation is the least penetrating, then it's beta, with gamma being the most penetrating. Alpha, beta, and gamma radiation also have different ionizing powers. Ionizing power is the ability to remove an electron from an atom. Alpha is the most ionizing, thanks to the particle's relatively large mass and charge, and gamma is the least ionizing. It does not interact with matter as much. You need to memorize these 3 types of radiation in order of penetrating power and ionizing power for your exam. Alright, here's a worked example. A radioactive sample is emitting an unknown type of radiation. A researcher places different materials in between the sample and a Geiger counter. The results are shown in the table below. The background count rate is 17 counts per minute. State the type or types of radiation emitted by the sample, explaining your answer. This question is worth 4 marks. First, let's highlight the command words. These are state and explain. It's always a good idea to look at the thinnest material first, which is paper here. With a paper shield, the Geiger counter records a count rate of 53 counts per minute. Comparing this to the reading without paper, 76, we can see the paper has reduced count rate. This is telling you that the paper is blocking some radiation, which hopefully you know is alpha radiation. Write that down and you've already got 1 mark. Remember, the command words were state and explain, so we need to include our evidence for this. It's because the count rate is lower when paper is introduced. Mark 2. Let's also compare the paper count rate to the background count rate, which is 17 counts per minute. 53 is much higher than 17, so another type of radiation must be passing through the paper. We need more clues, so let's have a look at the aluminium shielding. The count rate is almost identical to that of paper. This tells us that whatever was passing through the paper was also passing through the aluminium. Beta radiation certainly can't do this, so it must be gamma. That's the 3rd mark, but we need to explain. The fact that the count rate doesn't drop to background with an aluminium shield tells us that gamma is being emitted, so we get the final mark. Tables like these can be confusing. Draw a diagram with the count rates for each material if you need. In summary, some nuclei are unstable and can emit alpha radiation, which is a helium nucleus, beta radiation, a fast electron, or gamma radiation, which is high-energy electromagnetic radiation. Gamma passes through materials the most easily, and alpha is easily blocked by paper or skin. And alpha radiation is the most ionizing, with gamma being the least ionizing form of radiation. Don't forget to check out all our other fantastic revision resources at Save My Exams.